Hello students, welcome back to the video lecture series of numerical methods in chemical engineering. We have started unit number 6, that is numerical differentiation and integration. We have already derived the formula for numerical differentiation for equal intervals. In equal intervals we have derived two formulas. One formula was from the Newton's forward interpolation formula, and the another formula was from Newton's backward interpolation formula. What is the basic difference between both of them? The basic difference is only in the sign and the notations. The values will be taken from the same table, right? We have to draw one same table, and from the same table we have to take the values. If Newton's forward interpolation is there, then we have to take the first value of the table, and if Newton's backward interpolation is there, then we have to take the last value of the table. So in forward interpolation we are taking y0, and in backward interpolation we are taking yn. Okay. See, for equal interval interpolation we have to find the numerical differentiation with the help of that formulas that we have already derived from Newton's forward as well as Newton's backward. But what in case of unequal intervals? See, the numericals of unequal intervals can be solved by first of all finding the interpolating polynomial, and then after taking the derivative of interpolating polynomial we can find the answer by placing the value of x in that particular function, right? So let us take one example on the basis of that. See, in this case also, in this numerical also, what is given? We have to find y dash at x is equal to 5. Some values of x and y are given, three values are given, x0, x1, x2 and y0, y1, y2 are given. And in this case, how we can identify that we have to apply forward interpolation or backward interpolation or divided difference or Lagrange? How you can identify that? See, here we cannot apply Newton's forward or backward interpolation because it is a numerical of unequal interval. How we can say unequal interval? Because the difference in the values of x is not same. You can see 2, 4 and 9. See, the difference is not same. So they are located at unequal intervals. So in this case we will first of all find the interpolating polynomial, and on the basis of that polynomial we will find the derivative. Okay, so first of all we have to find y. Here we will use, here we will use Newton's divided difference formula. Okay, that will be more easy for you. So let us solve this. See, before starting, first of all we have to make the divided difference table. So for that we are having x, y, first divided difference and second divided difference. Let me write the values of x, 2, 4, 9, and the corresponding values of y are 4, 56 and 711. See, here we have to solve the whole numerical with the help of Newton's divided difference interpolation. Okay, it is a numerical of numerical differentiation, but first of all we have to find the interpolating polynomial and then we have to take the derivative, right? Okay, how you can find the first difference? See, this can be found by 56 minus 4 divided by 4 minus 2. See, 56 minus 4 is 52, 52 divided by 2. I am writing it. Okay, so what will be my value? 26. Similarly, 711 minus 56 upon 9 minus 4. So it can be written as 131. Okay, how you can find the second divided difference? See, if you remember, in the second divided difference, we have to take the difference in the values of y. So 131 minus 26 will be there, and we have to leave a value of x in between. So 9 minus 2, and 9 minus 2 is 7. So what will be my answer? My answer will be 15. So these are my values that I have to take in the Newton's divided difference formula: 4, 26 and 15. Okay, So let us write the Newton's divided difference formula. See, x is already given. What is the value of x? We have to take the value of x as 5. Okay. See, first value, that is f of x0 plus x minus x0 into f of x0 x1 plus x minus x0 into x minus x1 into f of x0, x1, x2. Okay, by placing all of these values, you can get the answer. See, what is our f of x0? Our f of x0 is 4. So instead of f of x0, I can write 4. Then x, what is x? X is 5. This is our x0, x1. Okay, then 26 and 15. So let us place all of these values. By placing the values, I can get the y of x as 4 plus x minus 2 into 26 plus x minus 2 into x minus 4 into 15. Let us simplify this. 26x minus 52 plus x square minus 6x plus 8 into 15. Let us simplify this. 4 plus 26x minus 52 plus 15x square minus 90x. Okay, plus 120. If you will simplify this, you will get the answer like this, 30x. Okay, see, this is my y of x. Now I have to find y dash of x. For y dash of x, the constants will be 0. So all of these values will be 0. So what will be my answer? The derivative of 26x is 26. Then 15x squared. So it will be 30x minus 90x derivative is 90. So 30x minus 64 is my value for y dash of x. What is my next step? See, I have to find the value of y dash at x is equal to 5. So simply I have to place 5 in place of x here. So it will be 30 into 5 minus 64. That is 86. So my y dash of x at x is equal to 5 will be 86. See, this is more easy. Okay. So in this way you can solve the numericals of numerical differentiation at unequal intervals. Let us solve one more numerical on the basis of this. See what is given. From the given table you have to find the value of x for which y is minimum. See, in this form numerical we are going to use the funda of maxima and minima. See, what was the condition for minimum to find the maxima or minima? We were first of all finding f dash of x and we were placing f dash of x equal to 0 and we were finding the value of x. Okay. See, here also we have to use the same funda. So first of all we have to find the formula, we have to find the equation of y, then we have to take the derivative, then we have to find the value of x for y is minimum, for which y is minimum, and then I have to find the value of that y. Okay. But in this numerical, which method we have to apply? See, it is equal interval. Okay, it is equal interval, so we have to apply Newton forward or backward. We will apply Newton forward interpolation formula. So to apply Newton's forward interpolation formula, first of all we have to draw the difference table. Newton's forward interpolation table, Newton's forward difference table we have to draw. 5 values will be there. Now the lines have become straighter. Okay. The first value is 3, 4, 5, 6, 7 and 8. Let us write the value of y: 0.205, 0.240, 0.259, 0.262, 0.250 again, and 0.224. Then we have to find the differences. So let us write the values. Here the value will be 0.035, then 0.019, 0.003, minus 0.012, 0.026, again take the difference, minus 0.016, minus 0.016, minus 0.015, minus 0.014, again take the difference, here 0, 0.001, 0. Okay, here again it will be, this value is 0, so we are not taking the further values, we are considering them to be 0. Okay, now which value we have to take in the numerical? Okay, so we have to take the first values. This is our y0, del y0, del square y0, del cube y0. By placing all of these values in the Newton's forward interpolation formula, what we will get? Okay, see, let us write the Newton's forward interpolation formula. P into P minus 1 upon 2 del square y0, and del cube y0 will be 0, so I am not writing that term. Okay, what is the value of y0? 0.205 plus P into 0.035 plus P into P minus 1 upon 2 minus 0.016. See, here I have to find the value of dy by dt. What will be my dy by dt? This term will be 0, then 0.035 plus 2p minus 1 upon 2 into minus 0.016. See, now for finding the value of p, for finding the minimum value, dy by dp should be 0. So I am placing dy by dp equals to 0. So 2p minus 1 upon 2 into minus 0.016 is equal to minus 0.035. So after solving this, you will get the value of p. What is the value of p? 2.687. See, this is the value of p, for which the y is minimum. But we have to find the value of x. How we can find the value of x? See, x minus x0 upon h is equal to p. So what will be my x? X will be x0 plus ph. What is our x0? 3. What is our p? 2.687. What is our h1? So what is my value of x? 5.687. See, this is my value of x for which the y is minimum. See, I have to also find the value of y for which the x is. I have to also find the value of y for the value of x where the y is minimum, right? So I have to place this value of x, or I have to place this value of p in this main equation, right? So after placing this value of p in the main equation, you will get the answer like this. We have to place p is equal to 2.687 in the main equation of y. You will get the value of y as 0.262. You all have to solve this and you have to verify your answers. Okay, I am not solving each and every step because you have to do it by yourself, because practice is must. Okay, it is not like that after solving only one numerical you will be the master. More and more practice is required. Okay, I have some time limitations, that's why I am not solving each and every numerical. If you are having any type of doubt, you can ask me. In the next lecture we will start numerical integration. Till then, have a good day. Bye bye.